Vanakkam. Now we are going to solve problem 3.90 from Fundamentals of Electric Circuits, 5th edition and 6th edition by Alexander Sadiku. So this is a problem related with the transistor, and given V0 as 4 volts, beta as 150, VBE as 0.7, we are asked to calculate Vs. Okay. So this is the circuit given. Now as a first step, we have to mark the terminals first. So this is our base terminal, and this is the collector terminal of the transistor, and this is the emitter terminal. By looking at this arrowhead, we know that it is a NPN transistor. And now we'll mark the currents flowing through this. Okay, so to the base, IB current will be flowing, and into this collector terminal, IC current will be flowing, and out of this emitter terminal we have this IE current flowing. Okay, and this base to emitter voltage is marked here as VBE. Okay, and this is plus and minus, the polarity. And between this collector to emitter we have this VCE, collector to emitter voltage, and the polarity is like this, plus to minus. Okay, and this V0 is nothing but VE, voltage across this emitter resistor, and this is also equal to, you should know that it is IERE. Okay, and this polarity we can mark it as plus minus. So at the input side, clockwise direction will show the current flow. So current starts flowing from here. So it starts flowing in this direction, and it is flowing this way through this 10 kilo ohm resistance. So that we have to mark the polarity as plus minus. Then this potential is VBE. Then from here to here the current is flowing. So it is plus to minus. Already it is also given here. Then it ends here. Okay. So with this detail we can proceed further. So we know that this V0 is equal to voltage across the emitter. So that is given in the problem as 4 volts. And this VE can be written as Ohm's law. By Ohm's law we can write VE as IE into RE. And in this V0 is 4 volts, and this IE not known, RE is available in this problem as 500 ohms. So we can write IE as 4 divided by 100. And so we calculate this IE value as 0.008 amps. So we have noted this. Now we know the current equation, IE is equal to IB plus IC. Okay, emitter current is equal to sum of base current and the collector current. And we also know that this IC can be written as beta times IB. So if you take this IB outside, it is 1 plus beta. Plus beta is given in the problem as 150. So if you substitute that 150, we'll get this as IB into 1 plus 151. And so we get this IE as 151 IB. In this IE value we have already calculated as 0.008 amps. So if you substitute it and calculating for IB, we get this as 0.008 divided by 151, that is equal to 0.00005298 amps. Okay, and it can be written like this: 52.9 into 10 power minus 6 amps, or it is 52.9 microamps. So we got the value for IB. Now we are going to apply KVL at the input side. What is KVL? It is algebraic sum of the voltage in a closed loop is equal to 0. Okay, so for that we have to start from here, and then the current will be flowing in this direction and ends here. Okay, so for that we know all the polarities already applied, so we can now start writing this KVL at the input side. So it is minus Vs plus 10 into kilo ohm, right? So 10 power 3, that IB current is flowing. This is Ohm's law, I R. Okay, R is 10 into 10 power 3. I is IB, base current, plus this VBE, and then plus this V naught, that is equal to 0. And in this, we know the value of this VBE, that is 0.7, and also V naught is 4, which is given in the problem. And IB is also we have calculated, so it can also be substituted. So it is minus Vs plus 10 power 4. 10 power 4 is this one, right? So 10 power 4 into this IB already we have calculated as 52.9 microamps. So it is 10 power minus 6 instead of microamps, plus this 4.7, that is equal to 0. So we have only one unknown parameter. So here this is 10 power minus 6 and 10 power 4. So we can write this as 0.529, okay, because it is 52.9 into 10 power minus 2, so that can be written as 0.529. So we have this as minus Vs 0.529 plus 4.7 is equal to 0. That means Vs is equal to 5.229 volts. This is the answer we need. Okay, so we got the answer. So the answer is Vs is equal to 5.229 volts. Thank you.